Alright, so we left off with this graph. We chose letter D as our final graph. The next thing they asked me about is domain and range. So imagine smashing it all onto the x-axis and which value you would be missing. So you'd have a lot of negatives, right? You'd have a lot of positives, but there would be one value missing in the middle, and that's right there at that asymptote. So your domain would be all real numbers except for -4. And like I said, I don't care if you circle the multiple choice answer or if you write x does not equal -4. Likewise, if you took the whole graph and smashed it together onto the y-axis, okay, you would have every single positive, every single negative, except for one negative. One negative would not be there, and that's the horizontal asymptote right there. And so the range would have everything except -3. And once again, I don't care if you circle this or if you write y does not equal -3. You get the same, that's saying the same thing. On question 1 on the next page, we first looked for a greatest common factor. The greatest common factor of the denominator is 5x. So we pulled that 5x out, and that left us with 5x minus 1 on the bottom. All we're doing is pulling out the GCF. And then, of course, we saw that there was a 5 that you could cancel and an x that you could cancel. And just remember, whenever you canceled all the factors out, there's always a 1 sitting there. I joke around with my good friend Juan. And but a lot of people forget 1. And so 1 over 5x minus 1 is your final answer. Remember, don't worry about that stating your restrictions on the variable stuff. I'm not asking you those kind of questions on any of these. On question 2 here, we see a greatest common factor right there of 2. And we pulled that out right here. We take a 2 out of that, we get x plus 7. Alright? There's no way you can simplify x plus 9. That's as simple as that one gets. But then these other two, you can break these two up into, there's no greatest common factors to worry about, but you can break them into their parentheses. And you can start thinking about what multiplies to 24, and -24. If it's multiplies to a negative, you got to have 1 plus and 1 minus. And then adds up to 5. So I wrote out the factors over here, 1 and 24, 2 and 12, 3 and 8, 4 and 6. And obviously the 3 and 8 combo is the one that works. 8 being positive, 3 being negative, that adds up to 5. And then I come down here to the next one. If they have to multiply to a -21, then 1's a plus, 1's a minus. Your factors of 21 are either 1 and 21 or 3 and 7. That's it. That's all you got. And so it has to be the 3-7 combo to add up to +4 with a +7 and a -3. And then we look for what cancels. Obviously, the x minus 3 is canceled. And then you got an x plus 7 here and an x plus 7 there, and they cancel. So that leaves me with a 2 and an x plus 8 on the top and an x plus 9 on the bottom. And no, you don't need to distribute anything on that top. I mean, if you did, if you wrote 2x plus 16 over x plus 9, that would also be an acceptable answer. There's nothing wrong with that one either. But I would say this one's just as good. Okay, question 3. So, I don't see any greatest common factors anywhere. So I can immediately do the double parenthesis here, 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 and here. So, what multiplies to 12? I wrote them out here, 1 and 12, 2 and 6, 3 and 4. And they have to add up to -8, so we went with -6 and -2. Multiplying to -4 would be a +2 and a -2, because they have to add up to 0 because there's no term in the middle. This would be 2 and 1 because they add up to 3. And the only only one in the bottom right corner. This one is the one that tricks a lot of kids because they like to do 2 and 3. But the problem with that is it does not give you a -5. Because one of these has to be a plus and one has to be a minus, because they multiply together to give me a -6. So we do have to have a +1 and a -6. But what we ended up finding out is, like, those two canceled, those two canceled, these two canceled, these two canceled, and we had everything cancel out. Well, anytime you have that means you have the same thing on the top as you do on the bottom. And just like anything, like 8/8 or 17/17, that's always equal to the number 1. Like I said before, if you cancel everything out, you still have a 1, right? So it's like having 1 divided by 1. So, question 4 right below that, I came up with this phrase, keep, change, flip them, to try to, and the M I just added on the end just to see if you would remember that it's multiply. Okay, just keep that in mind. You're changing it from division to multiplication. I do see a GCF here. They both have a 5 in common. And the reason that's important is because of what you're about to see. Pulled out the 5 and that left us x plus 7. That part went on the bottom. Right? Because I did the flip them part. And the 2 went on the top. And then we looked to see what canceled. And the x plus 7's canceled. And that left me with a 2 on the top. 7 times 5, which is 35 on the bottom. That's my final answer. Question 5. No GCFs. No GCFs at all. Okay. I do not want to write this multiple times. So I wanted to write it only once. Now we had to figure out things that multiply to 12 and add up to 7, so I did my factors of 12 right here. 1, 12, 2, 6, 3, 4. We had factors of 36, 1 and 36, 2 and 18, 3, 12, 4, 9, 6, and 6. We had factors of 27, 1 and 27, 3 and 9. And lastly, factors of 18, 1 and 18, 2 and 9, 3 and 6. So we chose 4 and 3 to add up to 7. We chose 4 and 9 to add up to 13. Hold on a brief minute.
All right, I finally figured out my audio problems there. But, so to get it to, it's a positive, no, that's a negative. It's a negative, multiplies to a negative, but adds up to a, oh, okay, yeah. Multiplies to a negative, adds up, they're both negatives, aren't they? No, that's a plus. Boy, if I look real close, I can see that's a plus. Okay, that makes more sense. Plus, but multiplies, adds up to a negative. And so I looked at my 18, and the one that would work would be 3 and 6. Now remember, since I'm doing the keep, change, flip, why can't you see my, oh, because it's unplugged, dang it. Okay, I'm back. Got my technical difficulties figured out. So this one up here is going to be coming down to the bottom because of the keep, change, flip idea. So the -3, -6 had to come to the bottom. This one is going to come to the top. It had to multiply to a -27, add up to a +6. So that's why we chose +9 and -3. I just didn't want to write it more than once. So we kept the first one the same, changed to multiplication, flipped the second fraction over. Now we could start looking for what cancels. The x minus 3's cancel, the x plus 9's cancel, the x plus 4's cancel, and that left me x plus 3 on the top and x minus 6 on the bottom. Give you a second. Pause if you need to, copy down or cross things out. before I go to the next question. Okay, so we're skipping question 1 there, so you don't have to worry about that one. And then question 2. Be really good. Okay. Question 2. We see that they have common denominators of v minus 4, so we do not have to do that thing where we were like, okay, what's this denominator missing that the other one has? We don't have to do that with this question because it's already got common denominators, so that stays the same. It's just now we can add the numerator. You got 2v plus 1v, which makes 3v, and you got 8 plus 8, which makes 16. So that's the answer to that question. Question 3. So I see a GCF right here of x that we can pull out. And if I pull that x out, I'm left with x minus 8. The red part wasn't there at the beginning. So that part wasn't there. And then the next one is I see a GCF of 8 that we could pull out, and that left me x minus 8. Once again, the extra part that's in red was not there. Now, remember how I also told you that a lot of kids make mistakes with subtraction? So push the subtraction symbol up to the numerator, which changes this to addition. There's just fewer mistakes made if you do that. Okay, so I asked myself, what is this denominator missing that this one has? And obviously the answer is 8, top and bottom. What is this denominator missing? Well, this one has an x, so it's missing an x, so top and bottom. So on the bottom, we have 8x times x minus 8. That's the common denominator. And on the top, we have 8 times 8, which is 64, minus x squared. X times x being x squared. And I said to you in class, this is full credit when we did this before. If you leave this answer just like this, full credit. There is a possibility for extra credit here. So I can see that I can take a negative 1 out of the top. That reverses the top, makes it x squared minus 64. Okay? Now, that's a difference of perfect squares. So that can be broken apart into x minus 8 and x plus 8. And then, of course, the reason we did that is so that the x minus 8s would cancel out. Excuse me. So here's your extra credit answer if you're interested in doing that. But once again, I said to you this. If you want to give the full credit answer and stop with that, you're more than welcome to do that. Question 4. Pause if you need to get caught up if you're copying things down. Question 4. So, we don't have any GCFs here. We do have that negative, just like on the last one, so I brought that up to the top, changed it to addition. They need to multiply to negative 3, so that's a positive and a negative. And add up to positive 2, so we went with plus 3 and minus 1. They have to multiply to 3, but add up to negative 4, so that means they both have to be negatives. And 3 and 1 are the only two choices you have, or the only choice you have, I should say. And then we say to ourselves, what's this one missing? This one doesn't have an x minus 3, so top and bottom we went with x minus 3. And then we said, well, what's this one missing? Top and bottom, x plus 3. So the common denominator, and as I said in class many times, I do not care what order you write these 3 factors in as long as you have the 3 factors. Mix them up however you want. And don't worry about foiling the bottom. But in order to combine the numerator together into one fraction, we will have to distribute. 3x times 1x is 3x squared. 3x times negative 3 is negative 9x. Negative 6x times 1x, negative 6x squared. And negative 6x times 3, negative 18x. So it looks like there's a couple like terms, like this is a like term to this. And that's when you add those together, you get negative 3x squared. And then this negative 9x and this negative 18x make negative 27x. And then you're done. You got everything you need. Okay. Sounds good for the end of this video.
Okay, so this is where we left off. I don't like doing these things vertically, so I make sure to rewrite them horizontally. I suggest you do that now if you're taking notes with me.
This is chapter 10.
Chapter 10 still, yes. For those of you not taking notes with me, work on other homework, relax. What are you going to tell me? Nope. Okay, what's this denominator missing? It's missing a 7. There we go. Multiply the top and bottom by 7. So now the common denominator of that parenthesis is 7. If only we could figure out what 3 times 7 plus 6 is. 3 times 7 plus 6. That is 27. And what is the other one missing? It's missing an 8, thank you very much. So, 2 times 8 minus 5 is how much? That's 2 times 8 plus 5. I need 2 times 8 minus 5.
Oh, minus 5.
11. And now, it's time for the keep. Change. Flip 'em. Keep change. Flip 'em. Nothing reduces. Just multiply. Ooh, 27 times 8. Already had it on my calculator. 216. 7 times 11, 77. We are done with the question. Nope, nothing reduces. The top is based on 3's and 2's, and the bottom doesn't have any 3's and 2's in it. Otherwise, I would. Any questions on this? Yes.
You told us, but why the
For multiplication. Just to remind people that we are multiplying. That's the only reason. Flip. Yep. You guys okay?
Fantastic.
Okay. Alright, okay. Okay. As long as it was not something before math class. Okay, 8 over W plus 5 over x divided by, well, don't want you taking things that you shouldn't be. 5 over w, minus 8. That kind of stuff might fly in another class, but it doesn't in here. It's just a joke, folks. I don't really suspect that. Not from you guys. So, what is this first one missing? What's it missing? An X, thank you very much. What's this one missing? A W. So together that would be 8x plus 5w over wx. This one obviously is missing an x. This one's missing a w. So what's the top of that one going to be? 5x minus 8w. Now what? Keep change, flip them. Keep the first one. Change to multiplication. Flip the second fraction. Do we see anything that might cancel out? How about those WX's? That's true. But because of the addition and subtraction that you see there, nothing else cancels, so don't try it. 8x plus 5w over 5x minus 8w. That is the final answer, yes. I wouldn't see you could possibly do some things with rates, but not a ton of things you're going to see with this. However, understanding logic and rules and how things fit together, you'll need that a lot. Things you can and cannot do. A lot, yes. There are applications that we do have throughout all of life, but then there are things that are in math that strictly are for the logic, and making sure you understand how logic works. What'd you say? Oh, me too. Me too. Yep, I wish we had them. Oh, here, I need to write this so you can actually read it. Oh, yeah? Okay, so they both have the same denominator, and when we had an equation and we had the same denominator, we did something like this. We said multiply by x plus 1 to the entire equation. And what magical thing happened? What? No, but it did simplify. What happens? Okay, I remind you, the denominators are all gone now. 11 equals x plus 9 is a much easier equation to solve. So, when you subtracted 9, what was your final answer? 2. Thank you. We should limit that to... Fill it out. Yeah, I know. No. No, but I should just have some sort of policies. Like coming late to class and then expect them to leave. Those kind of things. It's not like you were coming from outside the building. You were inside the building. Lift the paper? Oh, you mean lower it down? Gotcha. Ah, come on, man. I'm telling you, that's pretty cool, man. You get to walk down there. No, I get that. But, I think it's pretty cool, Inspire the little children, Right. They last year was the first year they started it. Because one of my students said, "Hey, I've heard them do this at other schools. Can we do this?" And so we made it happen. So. Oh, yeah. That would be kind of cool. All right, what are we missing for the first one? 5. That's right, top and bottom. What are we missing for the second one? Why? That's a good question. All right, now, the last one doesn't have anything that's missing, so we're ready to multiply the entire equation by the common denominator. What happens to all the denominators? They all get canceled out. Remember, that's only true for an equation. Don't try that trick on other things. So 40 plus 2y equals 4. Take a minute to solve it. Got it? What'd you get? Positive or negative? Oh, negative. You would be correct. I'm going to copy this down here because not enough space. Oops. So I kind of gave this part away that we were missing a p plus 2 on the bottom of this first fraction. What are we missing for this one? Just a p, right? And are we missing both of those things in the last one? We sure are. And of course we're going to multiply everything by the common denominator p times p plus 2, which eliminates all my denominators. And so now I have to distribute. Lots of distributing. Hopefully not to minors. 17p plus 34. 17p plus 34. Then the next one. 6p squared minus 7p. I really ran out of room. Equals. On the other side, 6p squared plus 12p. In my really poorly designed equation here, since it's going downhill, is there anything on both sides of the equation that we could get rid of? Anything you see on both sides of the equation that we could get rid of? How about the 6p squareds? Thank you very much. Those are eliminated, one from each side. If I combine like terms and I take 17p minus 7p, that would be 10p plus 34 equals 12p. A much more manageable equation. Assuming I have room. Should get an answer in the teens. You are correct. Nicely done. Alright, so if I take away 10p from both sides, I'll give myself 34 equals 2p. And divide out the 2, 17. That is ugliness based on. Any questions on that? Alright. That's good news. Okay. I'm shocked that he keeps a show. Okay. Alright, so the first denominator. What multiplies to negative 7 but adds up to 6? Well, one's got to be plus and one's got to be minus. How many things multiply together to give us 7? Not a whole lot, right? Okay. That would seem like a very odd pair. I will tell you that right now. Okay. Alright, so r plus 7 and r minus 1 would be the factors for those. What is this one missing? What is the second fraction missing? R minus 1. Excellent choice. Top and bottom. What's the last fraction missing? R plus 7. Top and bottom. And what happens when we multiply the entire thing by r plus 7 times r minus 1? Now that we have common denominators. What? Come on, we've seen it several times, just recently. What happens? That's what I was looking for. All denominators are gone. So we have 2r minus 2 plus another 2r minus 2. Because when you distribute the 2, you get 2r minus 2. Equals 2r plus 14. For r at the end of this? 9, you are correct. Well, did you get to 4r minus 4? Oh, well, when you bring that over, you have to subtract it, so that would take you down to 2r. Well, if this were not an equal sign and it was a plus sign, then you could, yes. Okay. Any questions? Ooh. That's a great question. I don't even think they know.